Alright, let's look at problem number 6. So we want to find the indicated quantities for f of x equals 2x squared. Alright, so part A. We want to find the average rate of change of this function if x changes from 1 to 5. Right? So average rate of change can be found by f of x, f of 5 minus f of 1 all over 5 minus 1. Right, so we just plug in 5 into it, so it's a 2 times 5 squared, so 25 times 2, so that's 50. Right, then plug in 1, so that's 2, and then divide by 5 minus 1, so it's 4. So this is 48 divided by 4, which is equal to 12. Right, so 12 is the average rate of change from 1 to 5. Right, let's do part B. Slope of the secant line, right, so this is really the same thing as the average rate of change, and going from 1 to 1 plus h. So this is going to be simply f of 1 plus 1 plus h minus f of 1 over, right, so 1 plus h minus 1 would be h, so I'm just gonna write h, so this is just the difference quotient. Alright, so let's go ahead and then compute that. So if you plug in 1 plus h into that function, you get the 2 is over, should be there, so x is replaced by 1 plus h, so this is squared, right, minus, right, so f of 1 we just did that, so that's 2, right, so divide by h, right, so let's multiply it out, right, so it's a 2 and 2, so I'll just put the 2 in front, right, so I'm just collecting these 2's and then put it right in front because it's the same factor. So if you multiply out the 1 plus h squared, you get the 1 plus 2h plus h squared, by minus sign. Right, so 2 is factored out, so it's still going to have minus 1 and all over h. Right, then we can cancel 1 minus 1. Right, and another thing we can do is we have h in both terms, so I'm gonna factor h out too. So it's a 2 is factored out, so that's 2 right here. So h is in common, so I'll put h, right? So we pull h from 2h, so you have another 2, plus pull h from h squared, so you have another h, and all over h. Right? So again, we have a common factor on top and bottom, so you can cancel those. Right, so what you get is it's a maybe I should multiply out 2 times 2 is 4, and 2 times h is 2h. So this is the expression for the slope of the secant line. Alright, and part C, slope of the graph of 1 at the x equals 1. Alright, so this is going to be the slope of the secant line. If you want to find the slope, we just need to take the limit of the result from part B, which is 4 plus 2h, and then we set the h goes to 0. Right, then you can see that this guy right here is going to go to 0. So what's left is just 4. Right? So slope of the function or the graph at x equals 1 is 4. Alright, part B, equation of the tangent line at 1 comma f of 1. Alright, so if you want to find this equation, you need the 2 pieces of information. First one is you need to find the slope, and the slope is going to be, we know that it's 4, so that's from part C, and 2, and we need to find a point. So I'm gonna call it x1 comma y1, and which is going to be, so x value is given, it's 1, right? And f of 1 is, we know that it's 2, plugging a 1 into the function, right? Then by, if you remember, maybe I should write that down, point slope form, which goes y minus y1 is equal to m times x minus x1. Alright, so the answer is y minus y1, which is 2, and slope is 4 times quantity x minus 1. Right, that's it. I hope that this was clear.